Hey, it's Chris here from AV.technology. I'm here with Geoff McKinnon. He is the Director of Engineering at EAW. Welcome, Geoff.
Yeah, good to be here.
So, jumping straight in, I guess one of the key messages for EAW at this InfoComm is, I guess, demystifying adaptive, differentiating adaptive from conventional beam steering. Do you want to just speak to that for a minute?
Yes, absolutely. So with adaptive, one of the goals that we need to actually adapt, not just beam steer, is to get this high density of sources. So that's why we have on Anna, for example, here we've got 1 inch spacing for the high frequency, so that we can use those sources to create and sculpt a acoustic pattern that is anywhere from very focused to very wide. That allows us to cover directly below the array out to the far field very efficiently.
So I think, are we splitting hairs? Because just to be slightly controversial with you, but I guess, well, maybe what we're saying is that perhaps with line source, maybe the competitors have, gone down the route of fewer amplifier channels and putting things in the air which look very much like what you're doing, but they're sharing a lot of amplifier channels to get the result that they're hoping for. Am I sort of headed in the right direction?
Yes, so there's a few different ways to solve the challenge. We certainly have mechanically articulated line arrays as well. Can start with that as a basis. So if you look at a single mechanically articulated array module, in many cases that is a single acoustic source.
Yeah.
The challenge is when you add more,
Yeah.
now you're creating more than one source.
Sure.
With adaptive, we're keeping those devices close enough together within about a wavelength of their highest operating frequency, so that when you are a listener, you experience that as a single acoustic source, a single impulse. You don't have multiple time arrivals from differing acoustic sources.
Sure.
And when you look at, okay, you can take that mechanically articulated array and add more amplifier channels, yes, that gives you more resolution. You can provide a better result. You're still trying to correct for some challenges that system presents because you don't have that single acoustic source as a starting point.
But I guess from the beginning, well, at least from the Christian Hall beginning, he recognised that you needed to have the high frequency devices close enough, or fool them to be close enough by having the Axhead waveguide and doing it in that way. So have we kind of strayed from the theoretical ideal from VDOS and have just tried to sort of clutch fix a line source looking array? I guess all I'm saying is that there are it feels like there are competitors that are definitely packaging their high frequency drivers close enough, but you're still saying that you have a differentiating kind of design difference, or am I kind of barking up the wrong tree there?
So with line source, there's certainly a lot of validity to that as a solution. It's maybe a little simpler to understand, simpler in some ways to cable as an example, maybe for installation purposes or otherwise. You do need something like an isophasic waveguide. We have our own design for isophasic waveguide that we use in our line array systems, and one of the primary reasons to have that is so the source size matches its directivity. If you put a more traditional constant directivity horn in whether it's 10 or 12 inch tall line source, now you have lots of overlap in your
Yes.
Audience area between all of those cabinets at high frequency. What the isophasic waveguide allows you to do when you're mechanically articulating an array, each of those audience members is only hearing a smaller number of cabinets,
Sure.
of sources.
Yeah.
And where we're going with adaptive,
Yeah.
we see that as a step beyond that.
Sure.
Now we're getting sources close enough so that no matter where you are, that's recognized as a single impulse, a single acoustic source.
Sure.
You don't even need to worry about 2, 3, or 4 different arrivals. You're getting a single arrival.
So with your adaptive approach, is it about primarily about better control, dispersion control, or is it sound better, sort of objectively? Is there performance benefits as well as sort of dispersion control benefits?
Yes, and so we see it as better sound with fewer loudspeakers. So typically with a mechanical articulated array, you need a certain number of cabinets to establish the overall coverage area. So from the uppermost listener to the lowermost listener is some angle, and you need to articulate the array to do that. And that can leave a large number of resources actually allocated to a smaller percentage of the audience area. With adaptive, we can deploy a system that is physically smaller and simply digitally aim the sound where we need it to go. It's really to release it back to where it goes and have it align at all those listeners. So if you look at a typical allocation through a deep venue, we're using maybe only 25% of the resources for the front half of the room, and 75% go to the back. We don't need to do half and half, and you can see very quickly that starts to reduce the size of these arrays.
That must make it absolutely ideal for spatial, with say 5 or 7 frontal arrays that are all 3 or 4 deep, completely out of the way.
Yes, exactly. We have seen that. It's been, you've certainly been demonstrating it with ANA and AC6. We see both of those as very good tools because you can do 3 deep ANA, get it above, whether it's video or just up to the proscenium, whatever it might be in a venue. Same thing with AC6, like our demo room here. We have an AC6 immersive setup in there, and everything is above the sight lines of video, other things. That's simply not achievable with a mechanically articulated array.
So how does adaptive kind of get repackaged for the new column speakers? Tell us about that.
Yes, great question. So when we looked at doing something that was more architecturally transparent, that had the columnar aesthetic, we wanted to maintain the high performance capability of adaptive. So 2 of those aspects being its high output and the low frequency extension. So it goes down to 65 cycles, our AC6 column, even though it's still very narrow. So that's low enough to augment an 18-inch subwoofer size. There's no gap between those 2 systems, and then also it's very high output. So you can use a small system to achieve very high output. And some of the other benefits, we went with a dome tweeter based solution. So it's 30 dome tweeters and 6 6-inch woofers, and it sounds like a studio monitor as a result.
Do you see a situation where you might design a system that has that product with ANA, or is there kind of a hybrid situation where it might have the column style speakers sort of in delays or special effects, or I guess the more kind of surround speakers? Like, have you just seen sort of system designs that use both?
I think there may have been a few. I know primarily where, like you're talking about, AC6 works well is if you do have, whether it's a speaking event or graduation or other thing, and you need some delays. They're very low profile, so they can be placed within the audience and they don't actually obstruct any sight lines. So whether you have maybe ANA as mains or multiple AC6 as mains, they deploy together that way. Actually, I do remember where there is one deployment that in a concert hall in New York City, they're using ANA as the mains,
Yep.
and then they have AC6 are their fill speakers, so they have those filling in kind of the shadowed area beneath the balcony in the front, and there's an area to the rear of the arrays. They wanted to deliver the same quality of sound that the ANA was delivering to that concert hall, so they ended up choosing AC6 for that.
Gotcha. So I guess to wind up, Geoff, is sort of the message about that your adaptive systems aren't necessarily, they're actually pretty good value. They're not just like super expensive and priced, out of people's budgets because you use fewer of them. Is that
correct? Yes,
Yeah.
that's been. We
People's
have a lot
experience.
of end users, customers that come to us actually seeking a line source solution.
Yep.
And then when they do the comparison between our line source and an equivalent adaptive source, whether that's AC6 or ANA, typically they end up finding that AC6 or ANA is a better fit for their business or their venue because of the benefits that it provides.
Yeah. And I guess is the other message that you don't need a PhD to kind of design and deploy. Like it's a fairly easy prospect to design an adaptive system and deploy it. It's not super tweaky.
Yes, so on the entry level, AC6 has rear panel controls. You can actually, if you have a ground stack deployment of AC6 mounted on subwoofers, we've got hardware that does that. You can go to the back panel and enter the height that the AC6 is at, the front of the coverage, the back of the coverage, and it will actually just calculate the parameters within the loudspeaker. You don't need to attach a computer. If you do get to a more complex deployment, whether it's of AC6 or the larger systems, you can connect our resolution software. That's intended to be very easy to use. You can make your venue model as simple or as complex as you desire. You can use as simple or complex tools as you want. It's meant to be an easy enough entry point for someone who's used to making mechanical articulate arrays, or maybe they aren't used to those type of deployments. It's a benefit that a lot of people have said to be working in the sense of coverage. So when you look at a venue with adaptive systems, you're not looking at angles and aims. You're looking at, okay, what area do I need to cover? Where does my front seat start? Where is the last listener in this section? And being able to say, I need it to do this distance, and drawing that rather than needing to worry about what angle I have. Is my trim height? Do I get the correct angle, shape?
Sure. Yeah. Cool. Well, I'll leave it there. Thank you for your time and your expertise, and hope you have a good show.
Great. Yeah. Thanks a lot, Chris.